This video is going to help you find the equation of a quadratic function if you're given a sequence of numbers. For example, you have a sequence 3, 8, 15, 24. You don't know whether it's linear, quadratic or whatever, but you decide to test and you work out the first difference and you find it's 5, 7 and 9. So it's not linear because the first difference isn't constant. And then you see the second difference is constant, it's 2. So because the second difference is constant, we know that it's quadratic. Because the second difference is constant. Okay, we also know that our quadratic is going to be the form an squared plus bn plus c. And we know that the a in this case is equal to half the second difference. And that's equal to half of 2, which is equal to 1. So our t of n is equal to, so far, we know that it's equal to 1n squared plus bn plus c. So now I'm going to look at the first term here, 3, and I know that t of 1 is equal to 3, and that's equal to 1 by 1 squared plus b by 1 plus c. In this case, the 1 is the n, you see. So the n squared is 1 squared, the n is 1. And so that means we're going to have 3 is equal to 1 plus b plus c, and that means that 2 is equal to b plus c. So we've got our first equation. Now look at t2. Well, t2 is equal to 8. So we have that 8 is equal to, now we know that it's equal to n squared, which is 2 squared, plus b multiplied by 2 plus c. So 8 is equal to 4 plus 2b plus c. And that means subtract 4 from both sides is equal to 2b plus c. Now I'm going to bring this equation over here. So 2 is equal to b plus c. I'm going to subtract to eliminate the c. 4 take away 2, I'm subtracting the whole lot. 4 take away 2 is 2, and 2b take away b is equal to 1b. So b is equal to 2. And if b is equal to 2, well, that means that c, so b is equal to 2, that means that c is equal to 0. So c is equal to 0. Because we have 2 is equal to b plus c. That means our t of n, I can have completed, is equal to 1n squared plus 2n, and that's it, because there's no constant, because c is equal to 0. So you've got your tn. Let's do another example. 9, 18, 31, we check what the first and second differences are to see. We've got 9 here, there's 13 here, and that's going to give me 17 here. And then 48 to 69 is going to give me 21. So the first difference isn't constant, so it's not linear. And then we're going to subtract here, we're going to get 4, 4, and 4. So the second difference is constant, so therefore it's quadratic. We also know that our t of n is of the form an squared plus bn plus c. And we also know that a is equal to half the second difference. So that's equal to half of 4. Which is equal to 2. So a is equal to 2. So our tn at this stage is 2n squared plus bn plus c. So let's now do t of 1. Well, t of 1 is equal to this one here, is equal to 9. So 9 is equal to, of this form here, n squared, which is 2, and n is equal to 1, because it's the first term. That's where this one comes from here. 2, 1 squared, plus b by 1, plus c, because it's the nth term. So that's the t1. I'm going to put a 1 in for the n's. That means 9 is equal to 2 plus 1b plus c. That means 7 is equal to b plus c. So now let's look at t2. Well, t2 is equal to 18. And 18 is equal to 2 times, well, n is equal to 2, 2 squared, plus b by n, which is 2, plus c. That means that 18 is equal to 2 2s are 4 by 2 is 8, plus 2b plus c. And finishing that off, I'm going to get 10 is equal to 2b plus c. Now, if I bring over this one over here, that's a 10. I've got 7 is equal to b plus c. So I'm going to subtract this from this one here. 10 minus 7 is equal to 3. 2b take away b is equal to b. And c take away c is 0. So I've now got the value for b. So b is equal to 3. We've got a is equal to 2, that's equal to a, and we've got b is equal to 3. And that means if you look at this one here, 7 is equal to b plus c, that means c is equal to 4. So our t of n is going to be n is equal to 2n squared plus bn, which is 3n, and then c is equal to plus 4. So 2n squared plus 3n plus 4 is our t of n. Okay, I hope that helped.